Welcome everyone to the EasyPower Tuesday Refresher webinar series. My name is Jim Chastain. I'm Applications Engineer here at EasyPower. And today we're talking about a topic that's often discussed and I don't think that well disseminated. We're going to be talking about what I call the method to import SKM files, and I emphasize method because I think you need to be fairly methodical in applying the process because it's not a procedure that one size fits all. So we'll get into the details of that. And if I don't mention it again, the details for that particular process are covered fairly well in the EasyPower User's Guide. So by all means, utilize it where you can or where you have questions. I'd like to start with a couple of poll questions just to get some feedback. No obligation or liability, but I would appreciate your perspective. And the first one is, which tool suites do you have or currently own? And this pertains specifically to the topic of importing SKM tools files into EasyPower. So let's give this a couple seconds to amass. Looks like we're about 50% to a quorum. All right, a couple more seconds. Okay, here's how folks have weighed in. All right, thank you. Next question is, why specifically are you attending today's presentation? Again, this is more subjective, but I would appreciate some feedback. And this, again, it goes to the emphasis on the methodology and the need to be a methodical converter, because it's a learning curve that's only gained by doing the process. So let's give this another 10 seconds. Thank you. Here's how people have responded there. And then just out of curiosity, I'm curious as to how many people have utilized the new database browser features in EasyPower 11.0, those of you that have EasyPower. Or at least you keep it updated with the current revision. And the reason for this, you'll see as I get into the presentation, is that a lot of the features that we utilize in the import process are again available in the database browser. So here's how folks have weighed in. Excellent. Okay, let's get on with the show. Now, it's fairly necessary, well, it's important to understand that the CSV file that has to be imported from SKM has to be created in SKM. And in the user's guide, EasyPower User Guide, starting on page 601, there's a description of two different procedures to create this export file from SKM. So I'm not going to be covering that, but I will be covering everything from that point on. So now I hesitate again to call it a procedure because it's not a single button press and it's not one size fits all. But what I'm going to emphasize are the procedures or the capabilities in EasyPower that give us the ability to resolve issues that occur when we do this import of this file. And these include an error log that's created, mapping files that we will describe a little bit, and then ways to improve the error results as you go through this. So once you've saved the import CSV file from the SKM tools, you want to put it into a folder that also has a subfolder called mapping files. We'll talk about those briefly. But once you create the import or click on the import button, it does create the .dez file with the same name as the import file. It does create an error log, which you can save or not sometimes, and what we're looking for is a successful import of the data. But most of the time is going to be spent on analyzing the import results, which is a separate report that we can utilize then to reduce the errors and improve the mapping files. Now, just as a spoiler alert, in EasyPower, there are some reserved keyboard characters that can't be used or shouldn't be used in the ID name. And so if you haven't been told this yet, you will get an error created if you use any of these characters in the ID name. Now, why that's important and why that's germane is that in the first import, I realized some of these names in the file had commas, and so you'll see what I used is Excel to find and replace commas with a dash. And so we're going to not even go into that detail, but you'll see what I'm talking about. So the import results folder or file looks like this. And what it shows is the equipment type, the ID name, and then the error that's being generated. And so the idea is to reduce the number of these errors because these have created a part number in the file or in the one line, but it's being underutilized because not all the data was imported. So the idea is to look for patterns. So for instance, in this particular import, we have a repeating pattern here for this breaker. It's all the same part number. This breaker is all the same part number, and we can see that we're getting the same errors in each location. So the discussion ends up being whether or not we create a mapping file to handle those errors or whether we do them manually. And so part of this process is to go in and look at the data that's actually coming in and see what's causing the mismatch, and then going to the dialog box for that individual device, looking at the tabs. In this particular case, we notice the specification tab looks like it's reasonable. As far as the data looks solid. If we look at the short circuit tab, it's auto-calculated and the part number has been retrieved from the device library, so that's a good sign. But when we go to the phase trip, we see none of that data has been imported. Now, one of the features that's available in EasyPower, and has been for some amount of time, is the ability to examine the collected data. So when we open up that folder, or that tab, we can actually see the data that came in on the import file from the SKM export. And if we scroll down, we'll notice down here under settings that this is all the information that needs to be entered into our phase trip. So at that point, we would, in fact, in this case, I did it manually. I made the corrections in the database, and chose to reduce the number of errors that we had that way. Now, I've referred to the mapping files. This is actually something that deals with the differences in the way SKM references certain elements in the database, and they can be consistent. And in very large files, it's very much, I guess, easier if you do a gross mapping examination, and specifically for multi-case circuit breakers, because they're less complicated than the associated low voltage power circuit breakers. So by improving these mapping files, you can identify the differences. So let me kind of get into EasyPower and let's talk about this. So what I'm going to do, starting with EasyPower, is to import an SKM data file that I've stored in a path that already has a subfolder called mapping files. And so this occurs under, I've done this in stages so we can see the progress. So here's my original export from EasyPower, some SKM. Turns out the mapping files are all blank, and I'll look at those in a second. But now by importing this data file, we will generate the reports that I was talking about. And so in the first report that shows up is an error report. And what it tells us is that the data has been successfully imported. It applied the mapping files, albeit blank as they were, but it went through the process fairly cleanly. And frankly, I might want to save this, but because this is the first pass, this is less important than this report, which is the import error warning. Now, this is where you're looking for patterns and you're looking for repeating errors. And it's also where I noticed that there were commas in my file. And if I go in and look at, let's say, this breaker here, as to what the problem is, I can either go to it on the one line or I can edit it in the data dialog box. And so what I'm going to do is look at the data dialog box. All right, I see it's a multi-case circuit breaker, but nothing came in as far as the manufacturer. So I'm going to look at the collected data. This indicates that the manufacturer is a Cutler hammer. So I can literally change or work around the missing data by mapping what I read manually from the dialog, the error report. And so this will show me the part number. It helps to be familiar with the elements, but we're looking for something that's rated for 100 amps at 480 volts, 25K interrupt rating. And it looks like it's a type FD. So I'm going to look under standard. It's not an FD. It's an FD15. And again, it helps to know the All right, so again, the process that I'm trying to emphasize is how to use this feature, and it looks like it's a Series C. So let's, all right, now with short circuit, it auto calculates it. It's rated for 35,000 amps. And so I see a discrepancy there that causes me some concern. So before I accept this, I want to go back and research that. Now, the other thing that shows up is it tells me I have an invalid text entry, and it highlights the ID name. And here's where I find that there's commas in the ID name. So at that point, I'm going to stop what I'm doing and go back and change my import. Let's go ahead and close this out. So I'm going to do two things. I'm going to close this file and change the import with the find and replace the commas with a dash mark. So let's try this again. I've saved this in a separate file. So let's go into import 2. Again, here, the mapping files are not blank. And I've actually started with, and we'll look at these in a second, started with recommendations from EasyPower on what my mapping files could include. So we're going to import this. And again, by two things going on. The errors caused by the comma should be eliminated. And now my mapping files are going to be applied. Again, it imported successfully. It applied the mapping files and had some issues. So I'm not going to save this. Now you can see my errors reduced considerably. And now the process is to go back, and it looks like I have issues with my low voltage power circuit breakers. So let's start off with this guy and see what's going on. Again, I'm going to rely on the equipment data tab, collected data tab. So it looks like GE was recognized, the part number, solid state sensor and plug. Again, short circuits identifying the part automatically from the device library. The part that's missing is my settings. So if I plot the TCC and I look down here at the settings input, settings string, I see long time pickup is set for 0.6. The long time delay is 1.5. Take that back. Long time pickup is 1. Again, this should match what's on the data sheet and what's in the device library. Short term, and I say that because if it doesn't, then we don't have the correct part number, and I need to do some research, either in the catalog or in the internet. So the short time pickup is 1.5 and the delay is 1. So short time pickup, and the delay is minimum. And then the only thing left is instantaneous. Well, actually, I squared T is on, which is in, and the short-term instantaneous, or the instantaneous, is 2.5 pickup. Now, and so this has been 102D, which is this puppy right here. And I'm going to clear this. It handles these errors down to here. Now, the advantage of doing this is that as I clear them, they will no longer show up on the error report. So if I were to save this file, let's say if I'm going to close it and save it, and close the one-line diagram, I can then open it at a later time. It gives me the original one line that was drawn, and then from my import, I can import the log and pick up where I left off with that device no longer on my error log. So once we've done that, and once we've eliminated these manually, these devices manually, then we would end up with a file that looks more like, let me kind of go to my third example. This is where we want to validate the data for still missing devices. So if I come back to import 3, okay, so this has had some amount of correction, and we'll see if I got an import log. Yeah, so now we're down to, we've resolved most of these as far as duplicated examples. And now we can go into the one line and either correct them here or go into the database browser. So if and the difference being any changes made in the database browser won't be recognized by the import log. So that's one disadvantage of doing it. Now if we look at our base case database browser, we can focus on each generic type of device and then examine things that are missing specific fields. So if our breakers, we can scroll down and here's something where the new shred is not showing up. We can go to the item on the one line. It looks like it's a fairly important element, so let's find out what's going on. And we see it's not reflecting any data, and it turns out it's a Cutler hammer with that wasn't recognized by our import. So again, this needs to be corrected and resolved. The one advantage of doing this in the database browser is that if the device list is displayed in alphabetical order, and so as I scroll through the different devices, I can see duplications that I can copy and paste into the next device that has the same settings. So again, having access to the SKM data file, thanks Mike, is relatively important. Okay, so what we've covered is how to improve the mapping files. I'm going to show those here briefly. how the descriptions can be accessed in the collected data tab on each element. And you don't have to be in the import mode to do it. You can do it anytime you have a one-line diagram. And then you want to correct as many as you can. The database browser allows us to inspect and research the validity of any data and modify it. And we just saw how that works here. Let me go in and look at my files. I want to make a point of looking at so in this procedure in the book that it lists the need to generate a mapping file folder. And it gives you a link to a web page or website in EasyPower that allows me to download this set of mapping files. But if you look at them, they're all blank. Now it's important to realize that these are not typical Excel spreadsheets. These are CSV specific. And so what that particular link gives me is a blank structure. And the description in the user's guide talks about anything that's within the segregation of the greater than or less than comments locations. It gives me what was imported. And if I want to map that to a specific EasyPower function, then I would put that element over here on the right side. So let me show you what something looks like when it's been populated. And so in my second folder, where I did utilize mapping files, now this set of CSV files, mapping files, can be requested from EasyPower, but there's no guarantee as to accuracy. It's strictly just the updated file that we use. But you can see it's a very good way to look at the way things are done in the equipment file or the mapping file. If you localize on the top row, then you can see how ABB, certain part numbers for ABB and certain functions get mapped with an EasyPower value based upon the recognition of that in the import file. So mapping files are very important and reduce the workload. Okay. So currently, devices that are imported without data include busways, current limiting reactors, CTs, filters, generators, relays, and transmission lines. Items that are not imported include this list, and this is straight out of the user's guide, but these may change in the future as more features are added. Now with the folder that we're using, the initial layout looks something like this, and it's relatively, because there's no coordinates associated with the part, it's relatively difficult to lay out anything that's similar to what was imported other than just the connections. But EasyPower gives us the ability, and it's difficult to see on this slide, but the different voltage levels can be color-coded, so you can drag in mass to certain sections to be lower in the system versus, say, higher voltage, which you may want to have higher up on the one line. But in this example, this total process was a 110 bus system. The total time took about 8 hours to do the whole import and resolution. And what I want to emphasize is that once you're done, even if you don't have loads on the buses, you still should be able to execute a power flow solution just to ensure the integrity of the design. So let me kind of go back and show that. So I have the finished file here that I can bring up and kind of resolve, or at least show how this is resulting. So again, this is not a one-step, one-button process. It is an evolving solution. And here's what resolved from that initial import with the 8 hours of work that it took. But as a result, we should be able to go to short circuit and get a clean one line, be able to fault the buses. And if we've got part number settings, we should be able to generate a arc flash result. Now, it's not to say it's coordinated. It's not to say it doesn't need adjusting, but at least the tool solves it, which means we have a clean one line. Likewise, we can go into power flow, get a solution set created there, and see power flow results. So what I've tried to describe is a iterative process of importing and resolving errors and improving the result. The two things that I really didn't highlight that much is if I go into EasyPower and look at the colors, if I look at the color options in my options file, I can change the equipment colors based upon the voltage on three-phase equipments. And so here's the scale that can be applied, and the colors can be changed. But by doing that, now I have darker colors for my higher voltage and the tan colors for my 480 volt systems. And if there's anything lower than that, I can do the granularity even smaller. And another tool or another capability is, let me kind of go back just is the ability to stub off cables. And that allows me to move things around without having to be concerned about the cable location. So for instance, this cable, if I look at the data block for it, it gives me all the details, which is part of the import. But then if I don't show the entire line to the load, to the subsystem, I can then select this or everything below it and move it to a different location. And then once I'm there, go back and reconnect the one line, or reconnect the cable description to show the entire line, and it'll redraw it no matter where it showed up, where I moved it. So that's another technique that's, I think, useful in the resolving process. Okay, again, all this is covered in the user's guide. Everything I've displayed here is part of the basic package of EasyPower, and certainly you have access to support at easypower.com if you want copies of the mapping files. And We appreciate your attendance today. Appreciate your time and attendance. If you got questions, you're more than welcome to shoot me an email, and that'll do it for my presentation today. Appreciate the help on the part numbers. So yeah, the question, does EasyPower have a service converted? The answer is yes. No, so I take that back. The conversion from an SKM is not something that EasyPower can do because we don't have SKM in-house. However, if you contact tech support, they can refer you to third parties that can do the conversion, do the setup of the import file from SKM. Now, the other part of the question that I answered inadvertently is, can EasyPower help with this resolution in mapping files? That too is answered yes, and I encourage you to contact sales or support at easypower.com and see what we can work out. Hopefully that helped. Have a good day.